Okay, so in our previous video, we have discussed about gases and vapor, and now we will discuss today about process which is cyclic process and non-cyclic process. So, what was cyclic process? Cyclic process is a system process which starts from an initial state and reaches to the final state, and the final state could be reached again to the initial state. In this condition, the u remains constant, that is internal energy. So there is no change in internal energy, hence overall heat, whatever change in heat is done, that totally converted into work done. So there is only the change of heat energy into work done takes place. So cyclic process and non-cyclic process. So cyclic process is a process which contains a series of changes which return the system back to its initial state. Okay, it consists of various changes which return the system back to the initial state, as we have just told, whereas the non-cyclic process, what is a non-cyclic process? It is a series of changes which do not return back to its initial state. So this is all about basic cyclic and non-cyclic process. What happens is, as we have discussed, that total heat energy is equals to change in work done. Whatever work done is by or on the system, that is nothing but the heat given. So let us talk about the work done in cyclic process. Let us consider this is volume and this is pressure. So initially the system was at certain pressure and certain volume. Let pressure and volume at this point be P1 and V1, and some energy has been given, and through a process it has reached to a state, final state, let it be B, P2 and V2. So when the whatever changes has been made, that is reversed, the system again reaches to the system again reaches to the initial state, that is point A. So what is the work done? This complete area under this minus this. So the remaining is the work done during a cyclic process is given by the area under this curve. So let work done by forward process, let this A to B, let it be forward process. So work done in forward process, let it be W1 is equals to area under A, let it be some more points also, let it be E, because A, B, C, D, E and F. So area under AE, B, AEB, C, D, A. And work done in backward process, work done in backward process, that would be, and this is minus, since the process is in opposite direction, so we can put a minus sign here. So starting from this point, B, F, A, D, C, B. So W1 will be minus of area B, F, B, F, A, D, C, B. So work done is equals to work done in forward process plus work done by in backward process. So we get this minus area of AEBCDA minus area BFACDB. So thus we get here AEBFA. AEBFA. So this is the total work done in the cyclic process. And in this case it is in anti-clockwise direction. So in this case it is from forming a clockwise direction, it is not anti-clockwise basically. So in this, the clockwise direction is being observed, means the overall system is expanding, and in this it will be positive. And if it is observed to be anti-clockwise direction, then in this case the overall area comes to be negative. So in this case the work done is by the system, and in this case the work is done on the system. Okay. So but we have to keep this in mind that in all the process overall internal energy remains same. Now let us talk about reversible and irreversible process. So reversible process Simple by the meaning itself, it tells you that if the process and the steps are being reversed at all points, then in this case, the process is said to be reversible. Means if the process be for passing through the same state when forward or backward. So when the process is forwarded or backwarded, it is passing through the same states. The intermediate states are same. Then in such case, it is a reversible process. So let us talk about the conditions of reversible process. First is it will remain in mechanical equilibrium. Second, means since it is a reversible process, in this process all the things mostly will be in equilibrium. So in this case the system will be in thermal equilibrium also in chemical equilibrium. So at all cases the equilibrium is achieved and there is no dissipative forces which are the reasons for losses, such as friction, such as viscosity, resistance, and so on. So what are the examples? Examples can be taken as the compression of an ideal gas. So compression of an ideal gas after slow expansion. So this could be treated as a reversible uh, process. Also, since it is also considered to be in chemical equilibrium, then electrolysis under balanced condition will also be taken as uh, reversible process. So, in the given examples could be treated as reversible process since the states through which the forward reaction has been taking place, the forward process, the same steps we have also observed when the process is reversed, means during the backward process also. Okay, now we will talk about irreversible process. So what is irreversible process? So let us talk about irreversible process. So it is very simple that if any process does not get its intermediate states to be repeated. So if any process does not get its intermediate states to be repeated during backward slash forward. Means either if it is, in both the cases, if it is not been seen observed that the states are being um achieved, so in this case where the process would be known as irreversible process. So the the condition is no, since there is no such uh, required conditions. So what would be the example? That basically most of the chemical equations are irreversible. So in that case, thermal equilibrium is not achieved, hence chemical equilibrium also not achieved. Hence we can consider it as a irreversible process. So examples, that chemical reactions which are irreversible in nature, and rusting of iron. Means these are some examples, chemical examples. And adiabatic process, adiabatic process. And also we can consider some, let us say, production of heat by electricity. When the electricity is being passed through the wire, it creates a heating effect, and due to which the electrons get disturbed, and this disturbance cannot be repeated. Means the electrons state could not be regained. So this could be considered as a irreversible process. So here your thermodynamics part is completed. We will now next move to the next chapter, that is kinetic theory.